Now let's look at finding the direction angle of a vector. If we know the components of the vector, we can always come up with the direction angle of the vector ourselves. So here I have a vector drawn as a position vector. So the initial point here is at the origin, 0, 0. Here's the terminal point. Okay, so this time let's say that we know how much to move left or right, and we know how much to move up or down, so we know A and B. Alright, and so let's say that what we really want to find then is the angle that's made with the positive x-axis. So that is what we want to find. So if I know A and B, what that tells me is I know the side that's opposite of the angle, and I know the side that's adjacent to the angle. So that sounds again like SOHCAHTOA. So tangent of theta is equal to opposite over adjacent. So tangent theta is equal to, the opposite side would be B, divided by adjacent side, which is A. Now if I want to get to theta, then I need to put that ratio into the inverse function. So tangent inverse of B over A is equal to our angle theta. Now frequently we use our calculator to figure out these direction angles. So we need to make a quick note on what the inverse function does and what your calculator is going to do. So when you plug a value that's positive, some positive ratio, into the inverse tangent function, then you're going to get an angle from quadrant 1. If you plug a negative ratio into the tangent inverse function, it's going to give you a negative angle that lives in quadrant 4. If you want a quadrant 3 angle, or if you want a quadrant 2 angle, then you are going to have to make an adjustment. And that adjustment is to add 180 degrees to the angle that the calculator gives you. So remember, when we do all students take calculus, tangent is positive in quadrants 1 and 3. But your calculator will only give you the quadrant 1 answer. It won't give you both of those answers. It won't give you both angles from quadrant 1 and 3. Okay? If you have a negative ratio, tangent is negative in quadrants 2 and 4. Alright, so your calculator is not going to give you both a quadrant 2 and a 4 answer. It's only going to give you one of them. It's going to give you a negative angle from quadrant 4. If you want to make an adjustment to get an angle in quadrant 2, you're going to have to add 180 degrees. Alright, so there is only one answer for each of these problems, but you might have to make an adjustment yourself to get the answer that you want. Alright, so the formula for finding the direction angle is to feed that ratio to the tangent inverse function, but if you want a quadrant 2 or a 3 angle, if you decide that's what's needed, then you're going to have to add 180 degrees to get to the right answer. Alright, so let's look at some examples using this direction angle formula. Alright, so we have a vector, 3, 4. What we're asked to find is the direction angle of the given vector. And so we're going to sketch it first. I always recommend when you're finding the direction angle that you sketch the vector first. Alright, so we're going to sketch this as a position vector. So I'm going to start at initial point 0, 0. And so that tells me to move to the right 3 units and then 4 units up. So there's our vector. Make sure you put an arrow to indicate the direction. Alright, and the terminal point is 3, 4. So we're asked to find the direction angle. We're going to do tangent inverse, 4 divided by 3. Remember, this is the A value, that's the B value. It's the second component, or the Y component, divided by the X component. Either way that you want to think about that. And that's going to give us our direction angle. Now, a key thing here is, where do we want that angle to be? Which quadrant? So if I start with a positive x-axis and I rotate in this direction, there's my theta. That should be a quadrant 1 angle. So I'm going to make a little note that I want a quadrant 1 angle to match my picture. So let's go to our calculator. Okay, we're going to do tangent inverse. We're going to do 4 divided by 3. And I get about 5.31 degrees. Okay, and once again, always do a double check to make sure that you're in the mode that you want to be in. We'll look for degrees. That's fine, so 53.1 degrees. Alright, and is that the quadrant 1 angle that we wanted? The answer is yes. So that makes sense with our picture. We're good to go with that angle. Alright, for our next vector, we have negative 5, 5. So I'm going to graph that. That's 5 to the left. It looks like 5 up. Okay, 5 to the left, 5 up. So we're going to start at 0, 0 again for our initial point, follow the directions, and then plot the terminal point. Connect them and draw our arrow. Alright, so there's our terminal point. Now, the angle that we want, let's talk about that. It starts at the positive x-axis and then rotates, and then we stop at the vector. That's a quadrant 2 angle. So we'll be careful about that. So we're going to use our formula, tangent inverse. It's the second component divided by the first component. And that's going to give us our angle theta. Put that into our calculator. Gives me negative 45 degrees. Now, we said earlier that we wanted a quadrant 2 angle. But the angle that my calculator gives me is, what is that? If I started at the positive x-axis and I rotated in the negative direction, that would be a quadrant 4 angle. So the calculator gives you negative 45 degrees, which is a quadrant 4 angle. If you get a quadrant 4 angle, that is not the correct solution. You don't want to give negative 45 degrees as your answer because we want a quadrant 2 angle. So how do we fix that? We're going to add 180 degrees. Alright, so I'm going to go back to my calculator and I'm going to say plus 180. So that gives me 135 degrees. That is a quadrant 2 solution, and that's the only solution that I'm going to report. So 135 degrees makes sense, it's a quadrant 2 angle. That is the direction angle for this vector. So make sure that you don't report this as a solution. There's not two solutions here, and this is the only answer that we get. All right, for our next example, we have negative 2, negative 7. So we're going to go 2 to the left. Remember, we're going to graph it again as a position vector, so we're going to start the initial point at 0, 0. So 2 to the left and then 7 down. So I'm going to connect those and put my arrow. Remember, we need an arrow for direction. Okay, so we're starting at the positive x-axis and we're rotating until we stop at the vector. And that's the angle that we want. And that is a quadrant 3 angle. Alright, so let's use our formula to find it. We're going to do tangent inverse. We're going to do the second component divided by the first component. And that's going to give us our direction angle. So I'm going to put that into the calculator. Alright, so my calculator gives me a positive 74.1 degrees if I round to the nearest 1 decimal place. Okay, so we said we wanted a quadrant 3 angle, but what did my calculator give me? It looks like my calculator gave me a quadrant 1 angle. So if I start at the positive x-axis and rotated 74.1 degrees, I would stop in quadrant 1. But my vector isn't stopping in quadrant 1, it goes all the way around to quadrant 3. So how do I fix that? Well, for tangent, there's a quick and easy fix. It's add 180 degrees to get to the quadrant that you want. So I'm going to add 180 degrees. We'll go back to our calculator and do that here. And it gives me 254.1 degrees when I round to the nearest 1 decimal place. And that is the quadrant 3 angle that we wanted. Alright, once again, make sure that you don't report 74.1 as a solution. There's only one solution to this problem, and it's that quadrant 3 angle. Alright, our last example here, we have 3, -8 as our vector. I'm going to start at the origin, 0, 0. We'll graph this as a position vector. So our initial point is there. We're going to go 3 units to the right, and then we're going to go 8 units down. There's our terminal point. So the angle that we want, we'll start at the positive x-axis, rotate around, stop right there. That is a quadrant 4 angle. So the answer I get must be in quadrant 4. So let's use our formula. Tangent inverse, we have -8. We want the second component divided by the first, b divided by a. That gives us our angle theta. Plug that into our calculator. So tangent inverse, -8 divided by 3. And I get -69.4 degrees if I round to the nearest 1 decimal place. Okay, so let's verify again. We wanted a quadrant 4 angle. Is that a quadrant 4 angle? Turns out that the answer is yes. That is a quadrant 4 angle. If we started at the positive x-axis and rotated in the negative direction, 69.4 degrees, then we would stay in quadrant 4. So it is a quadrant 4 solution, so it is a valid solution. The restriction on theta is that it must be measured from the positive x-axis. As long as it's measured from the positive x-axis, then the solution is fine. So we can put a box around that solution. Now there may be times when you will be asked to give an answer that fits within a specific interval. So let's say, for example, that you were asked to find all of your solutions between 0 and 360. If that were the case, then this would not include any negative angles. Now, if you were only asked to find positive angle measures that fit within those quadrants, then what would you have to do to get to the angle that you want? Well, in this case, then you would want a positive angle that started at the positive x-axis and rotated in the positive direction and stopped at exactly the same location. So you would want a coterminal angle that is positive. So how would I find a positive coterminal angle? Well, I could add 360 to the angle that my calculator gave me. So let's do that in Desmos. So that would be 290.6 degrees. So both of these angles are from quadrant 4. This would be acceptable if there were no restrictions and no interval given to you. that you could find a positive angle or a negative angle. It wouldn't matter as long as it's in the right quadrant. Or if you were asked to find angles specifically between 0 and 360, that would ask you to not have any negative angle solutions. You would just convert that quadrant 4 angle to a positive angle by finding a coterminal angle and adding 360. So this would be your final answer if this restriction were given on the problem.